Hi, I'm Paul. This is Science That Sticks. Everything you need to know about covalent compounds and covalent elements. Roll the graphic. Covalent compounds are different to ionic compounds. They obviously contain a covalent bond. A covalent bond is when two electrons are shared in orbitals, this is for GCSE by the way, between one another, and in sharing those electrons the shells become full and the atom becomes stable. Okay, so pretty easy stuff. Let's look at some examples of simple diatomic elements, then we'll look at some simple compounds. Let's go for it. Now then, I've got hydrogen, oxygen and nitrogen. Hydrogen happens to have one electron in its outer shell. So we need two of them in order to bond together because the electrons in hydrogen's shell are in the first orbital. And the first orbital can hold a maximum of 2 electrons. So therefore, this will look like this drawing right here. The cross and the dot indicate that one of those electrons belongs to that atom and the other belongs to this atom. The cross simply means it belongs to one atom and the dot means it belongs to the other. So you're denoting where those electrons come from. Now, oxygen's a different beast in that it happens to be in group 6, which means it has 6 electrons in its outer shell. So it needs 2 electrons to form a full outer shell, which would take 8. So it's not going to just share one of its pairs of electrons, it's going to share both pairs of electrons and form what we call a double covalent bond. Let's look. Now in this case, what I've done is I've denoted, first of all, the double bond, cross dot, cross dot. Now, if I look around this orbital, I know I've got to have 8 electrons in that orbital. 1, 2, 3, 4, 5, 6, 7, 8. This one's good. The crosses belong to this oxygen. If I count this way around, I've got 1, 2, 3, 4, 5, 6, 7, 8. This one is good. Therefore, both atoms have a full accompaniment of 8 electrons. It's fine. Nitrogen, on the other hand, happens to be in group 5, which means that little bad boy has 5 electrons and therefore it requires 3. So as a result, it's going to use 3 out of those 5 with another nitrogen to create a triple covalent bond. Let's see how it works. So what you can see here is I've got my 5 crosses that belong to this nitrogen. 1, 2, 3, 4, 5. It has to have 8 in order to be stable. So 1, 2, 3, 4, 5, 6, 7, 8. These dots from this atom are shared, and so it can be counted as being a full electron shell. But if we look at this atom, we've got 1, 2, 3, 4, 5, 6, 7, 8. This atom is happy. And therefore what we have is we've got a molecule of nitrogen with a triple bond. We've got a molecule of oxygen with a double bond, and we've got a molecule of hydrogen with a single bond. These are elemental and simple covalent molecules. Let's have a look at some compounds. Now, to keep this simple and straightforward, I'm going to look at just 2 covalently bonded molecules that are compounds. I'm going to look at water, H2O, and I'm going to look at methane, which is CH4. Now, water happens to have 1 oxygen atom covalently bonded to 2 hydrogen atoms. Remember, the hydrogens have 1 electron in their first shell. That is their outer shell. They need 2 to be full. Oxygen's in group 6. Because it's in group 6, it needs 2 electrons in order for it to become complete with the 8 that it needs. Let's draw the dot and cross. Now, here I've done it very, very quickly, but it shows everything it needs to. It is a dot and cross diagram again, and therefore I am showing the hydrogen's electrons as being dots. It also is accompanied with a cross from that oxygen atom. Oxygen now has 8 in this shell. 1, 2, 3, 4, 5, 6, 7, 8. It's happy. Hydrogen just needs the 2. 1, 2. It's happy. It's not happy, it's stable. It doesn't care whether or not it's got electrons. It can't think or have a sense of humour. But if we look at methane, methane will show the same thing. Remember, carbon is in group 4, which means it needs 4 electrons in order to have a full outer shell and be stable, with the other 4 that it has, making 8. Now, in this example, I could use the crosses as the carbon's own electrons, or I could use the dots, it doesn't matter. But for the sake of continuity, I'm going to use the dots belonging to the hydrogen. So this hydrogen has 1, 2, it's full and stable. This hydrogen has 2, it's full and stable. So does this, so does this, that's fine. But if we look at the carbon atom, we've got 2, 4, 6, 8. It has a full 8 in its outer shell, and therefore it is stable. This is how you do covalent bonding using dot and cross diagrams. It is a crucial skill to have for foundation students and for higher students. Heck, even if you're doing A level or AS level, they still ask for you to draw dot and cross diagrams for simple compounds and elements for that matter. So it's always worth learning them. The thing about the covalent compounds is they are small covalent molecules. Quite often they have a simple molecular structure, and they have very low melting points, very low boiling points, because they only have weak intermolecular forces holding them together, which do not require a lot of energy to overcome them, and therefore they have low melting points, low boiling points. That's it. As always, take care. See you all soon. Bye-bye. Oh, stay cool, and bye-bye.